time to build a little kit. Got this for 63 cents for a kit off of AliExpress, plus shipping, of course. I'll link all my times over here. I'll start off with a brief description of it, then theory on how it works, then assembling it, and then demoing it. And the reason I'm building this kit is because I have lots and lots of 555s, both surface mount and dip packages, and also some surface mount CD4017s and some dip 4017s. So I'm going to have lots of stuff to play with. So this is basically really two sections. You have the NE555, which is generating the clock signal that goes over to the decade counter. The 555 is set up in astable configuration, and the variable resistor here can go between 0 and 50,000 ohms. So if you wanted to change something, you could change this to even a higher value to get a lower frequency. If you go through these calculations, the lower or higher frequency is 65 hertz, and the lowest frequency is 12 hertz with this setup here. DigiKey actually has a nice little calculator on their website, and you just type in the values and it calculates everything out for you. So once it gets the clock on the leading edge of the clock signal, it actually advances the decade counter. And since the inhibit is grounded, it just cycles through again, and again. Well, I'm going to start with the NE555. And this is where these reverse tweezers, which I got a while back in mailbag 11, are going to come in real handy, because I can actually lock the chip into the spot and then solder it. So I've soldered 2 of the pins, the number 1 and the number 5, and now I'll get the rest of them. And that's pretty handy, being able to just lock it in place with the tweezers. And now I'm going to have to take a close-up look at it. So it's just a matter of getting 2 of these tacked down. That did not look pretty. And then I'll do the rest. And only bridged 2 of the pins. That's where the solder de-wick comes in quite handy. And next, the 1 microfarad capacitors. Clamp it in place, and then a dab of solder. And now the other one. So the 10K is now in spot, and now I'll do R2. So there's R2, which is 222, so 2.2K. Yep, I'm not getting a good... Hopefully I got enough solder on the iron. Okay. Wick time. Try to make it at least look pretty. And now I just step through the 1K resistors. And I'm not going to torture you with each of them. I'll just wave the hands and they'll magically all appear. And now the diodes. The longer lead being the positive. And I'll just flip it over and put them all in. And now it's just a matter of soldering them. They're all soldered now, so it's a matter of snipping the leads. And when snipping leads, use safety glasses. And next, the potentiometer. Then put the power connection on, and it's time to fire it up and see what happens. So, I did it again. I actually got myself reversed, and when I thought I was taping, I wasn't taping, and when I thought I wasn't taping, I was taping. So, I'll do the demo again. And I'm going to insert right about there a short section where you'll see that this LED here is not lighting. I then went through and found resistor was good, but pin 6 was actually not soldered down properly. So if I turn it all the way one way, that's going to be at about 12 hertz. And turn it all the way the other way, and you're at about 65 hertz, which is just a bunch of blinking lights to our eyes. I'm just going to slow it back down to a more reasonable amount. So there it is. And these are the tweezers I was talking about. I don't believe I had them well shown in it. Like that. And then when you release, they lock down nice and tight. And that way you can hold the part right where you want it. So this thing works. Just one little mistake with one solder joint. Yeah, not too bad.